With line integrals, we can also not necessarily integrate over the arc length, but we can still integrate line integrals with just respect to x and or y. So let's talk about that. If we have a line integral, but we just want to integrate line integral of f with respect to x. Let's think about that. So we're doing the line integral over a curve, f of x, y, all that's the same. However, I'm just going to integrate with respect to x. Okay? So instead of the arc length, we're just integrating over with respect to x. And this this kind of has tie-ins with the next section. So still parameterize it. D a to b in terms of t, f of x of t, y of t. But then, since we're only integrating with respect to x, this part turns out to be just f of t dt. See why? So if you think about it, this part is usually the square root of, well, we usually write it dx dt squared plus dy dt squared, but that's also x prime t squared plus y prime t squared. Well, since we're only basically we're doing the change in the x, the y doesn't change. So there's no change in y to square. It's 0, basically, right? So you have the square root of x. So this part is basically 0. And so you just wind up with x prime and t. Okay? So it's not that bad. Really nothing new. Just this part shrinks down. Okay. The line integral of f then with respect to y, guess what? Same deal. Is the integral a to b f of x of t comma y t, and then the y prime is all that shows up over here, dt. Right? Now, it turns out that we might want, again, this ties in with the next section, we might want these at the same time. We might have them both at the same time. And so the short, kind of the shorthand version of that is this. These appear together. So we're going to do a line integral over curve C again. P dx plus q dy. And so in other words, we've got a function of x and y dx plus function of x and y dy. We want to integrate with over the curve for that. And so, yep, just break them up. A to b, p p of x and y dx, which of course would be parameterize it. Parameterize it. In the notation here, they didn't parameterize it yet, but yeah, parameterize it there, and then do the same thing with the q, and then there's supposed to be a q there. Okay. So yeah. Well, it's just, yeah, you're integrating part of it with respect to x and integrating the other part with respect to y. So, like I said, it ties in more with the next section. Okay, so let's do one of those and see how that works out. I think these are the ones where they give us the line segment. Let's do one of those. All right, so let's evaluate. The integral c over c y x squared dx plus sine pi y dy, where c is the line segment from 0, 2 to 1, 4. Okay? So, again, to do these, we still need a parameter formula, and that's where the r of t vector comes in handy. It was, 1 minus t r0 plus t r1. So this will be 1 minus t times r0 is just this vector, endpoint, and then t r1 is just 1, 4. Zero, 2 minus 2t plus t 4t. So that'd be t and 2 plus 2t. Let's just add the components there. And so this is going to be our x of t. And this is our y of t. And t, of course, always in this case runs from 0 to 1. And so this line integral what's that now? Okay, yeah. It works out pretty well. It's not too bad. Yeah, I see what you're saying. But all right, so this is yx squared dx, and so that would be 0 to 1. The y is 2 plus 2t, and then x squared would be t squared. And then the dx, well, that's just the derivative of x, which would be 1, dt. And then we also add to that the integral 0 to 1 of this guy, which would be sine of pi times y, but y is 2 plus 2t, times, then dy, we do the derivative of y, which would be 2, dt. So of course this one's not too hard. This is just 2t squared plus 2t cubed, so that antiderivative would be 2/3 t cubed plus 2/4, which is a half t to the 4th, from 0 to 1, and so yeah, that's just going to be 2/3 plus a half. And then plus just a little u substitution here. Yeah, you can just say u is, that would be 2 pi plus 2 pi t. And so du would be 2 pi dt, so we're just going to have 1 over 2 pi times the antiderivative would be negative cosine of u, which is 2 pi plus 2 pi t. And we're going to go from 0 to 1. And look at that. Plug in the 1, cosine of 4 pi, negative 1, minus, plug in 0, you have cosine of 2 pi, negative 1 again, so that's just 0. Right? Okay. So it's 2/3 plus a half. I believe it's 7/6. Okay?